In our developmental psychology investigation, we're going to talk about aging in memory. And the reason, because that's what I do. I'm aging, but I'm also a scientist that's been looking at aging in memory over the last 35 years. And I'd like to talk about the conclusions that we've reached after doing lots of experiments on different age groups in their memory. The first conclusion is that age affects some memory systems, but not all memory systems. In other words, the decline in memory with normal aging is not ubiquitous. It actually occurs in very selective ways, and we'll look at those. Second, the differences between individuals within an age group are often greater than differences between age groups. So in our memory, we don't become more alike as we grow older. We become more different from each other. Third, age differences are reduced, attenuated, but not eliminated by consideration of other non-cognitive variables. So we'll look at how the memory changes and memory differences are there even when we consider other kinds of things. And then finally, older adults are especially susceptible to false memories or memory illusions that we talked about when we talked about memory earlier in the course. First, let's look at age affects some memory systems, but not others. When we talked about memory, we made some differences. We separated short-term memory into primary memory and working memory. Primary memory is simply how many items can we keep in mind at any one time. And working memory is the ability to process information and remember at the same time. And working memory is much more like how we use short-term memory in everyday life. And in long-term memory, we talked about three memory systems: episodic memory, the ability to look back and remember things that happened to us in a sort of internal diary; semantic memory, world knowledge that we have, so looking up things in our internal encyclopedia; and then procedural memory, which is non-declarative. It's not something we're aware of. How to do things, like ride a bicycle, or implicit memory that we talked about earlier, the ability to remember things even though we're not aware that we actually are remembering. Now, a study that we did, Denise Park and myself and lots of collaborators, we looked at different kinds of memory in a single experiment. We used primary memory, simply repeat back the numbers that I read out, digit span. We had working memory, which is computational span. We talked about that earlier. You have to do simple arithmetic problems and then remember words that come up with that arithmetic problem. So you're processing information at the same time you're trying to remember. We have episodic memory, which is simply a free recall task. What were the words you saw in an earlier list? And we have semantic memory, which is simply a vocabulary test to find the words that I give you. And finally, procedural memory, which was an implicit memory test, the word completion task, where I show a list of words and then later show you some word fragments, and you have to complete it with the first word that comes to mind, and you actually come up with words that you saw earlier, even though you're not aware that you're doing that. So we look at all of these memory systems and compare young adults to old adults. And the results, for short-term memory, we found significant differences in working memory, but not in primary memory, not in digit span, but in the computational span. Significant difference, where the statistic says that it would occur by chance only 1% of the time. When we look at long-term memory, we have three different tasks now. Episodic memory, the free recall task, where you simply repeat back words that you saw on a list, we get a significant difference. We also get a significant difference in semantic memory, but notice that the old group is better than the young group because we continue to, for vocabulary tests, we continue to read, we continue to experience the world, and it actually goes up over age groups. And procedural memory, the implicit memory task, no significant difference. So what we find then is that the differences are in episodic memory and in working memory. Just another example of this across different decades, you can see the free recall task, which shows the decline, significant decline, especially between 70 and 80. And for the vocabulary tests, we have an increase with age, which was significant, but the only decline was between 70 and 80. In fact, that's what we tend to find. So age affects only in episodic memory and working memory. Long-term memory, episodic; short-term memory, working. The second conclusion that we reached is that individual differences within an age group are often greater than differences between age groups. And let's look at, for example, in looking at digit span, we see a frequency distribution. That is, this is the number of people that you have that particular digit span frequency up till about, you can see up to about 40 people. And we see that we get these huge differences. For example, there are people in their 70s that have a digit span that are better than many people in their 20s and 30s. But even though the trend is that this will reduce with age, and I said this is a working memory span, so there's a decrease in span across age. That's the trend. That's what happens with the means, but the individual differences are still there. Another example of the individual differences increasing with age is Doug Powell's study with physicians at Harvard Medical School. He actually gave them a bunch of different memory tests and found that there was a decrease in memory performance with age, you see from 50 to 60 to 70 to 75, but a huge increase in variability. That is, the differences, individual differences increase over 100% over the same span. So the conclusion is that individual differences increase with aging, even though memory declines, episodic memory and working memory declines with aging. Thank you.